Now we'll start with the topic of fluid dynamics. In this topic, we are going to study and analyze motion of fluids. So, complete analysis and study of fluids in motion is termed as fluid dynamics. My first thing will be taking up the basics of fluid dynamics and some situations in which we analyze ideal fluids, and in some situations we analyze real fluids. So we can say for basic analysis, we use ideal fluids instead of real fluids, as real fluids have several limitations, and for an ideal fluid, we make some assumptions for a real fluid, and let's first discuss these assumptions, which when applied to real fluid it can be taken as ideal. Like the very first point about ideal fluid is streamline flow. We assume that fluid flow in a streamlined manner, and a streamlined flow is also termed as laminar flow. There's a situation in which a point, or you can say when a fluid body is flowing, then we can say at a point velocity of fluid particles does not change in magnitude or in direction also. So if a fluid is flowing, then at any point when fluid particles are passing at a specific point, the velocity in magnitude and direction always remain constant. Such kind of flow we term as a streamlined flow. In later part of the section, we'll discuss about streamline representation also. Let's first take up the second point, which is incompressible flow. And if we talk about incompressible flow, here we can say we assume that during flow, fluid density remain constant. Whereas in case of real fluids, it happens that at some point fluid density is more, at some point fluid density is less. But for idealistic situations, we assume that fluid flow is incompressible, it remains constant, or we assume that fluid density remains constant throughout the flowing body. Another point we use for this is non-viscous flow. As you already discussed about viscosity of fluid, so we can say in viscosity it is accounting the friction between different layers of a fluid. So we can say for an ideal fluid we neglect the viscosity between layers. In detail viscosity we are going to discuss in the chapter of separate chapter of properties of matter or viscous forces only. So we can say for ideal fluids, we neglect viscous forces between fluid layers. And the last point related to an ideal fluid assumption is irrotational flow. If we talk about an irrotational flow, we can say here we assume that fluid particles do not impart any rotational motion to the uniform bodies in path of fluid which are flowing, or we can say which are moving along with fluid. And this happens only when in a given cross section the fluid velocity can be taken a constant. So we can say, when we talk about fluid dynamics and we consider ideal fluids, so for ideal fluids we can simply state ideal fluid is the one in which always it flows in streamlines, it is incompressible, it is non-viscous, and its flow can be regarded as irrotational flow. Whereas in real fluids these properties are not exactly matching, these are deviated depending on the parameters given for a fluid. So you must be careful about all these assumptions, as we are going to use these assumptions for different cases in this particular topic.